Imagine this. Every year, millions of tons of pollutants end up in our wastewater, jeopardizing our environment and health. This is not a hypothetical scenario, but a grim reality we face every day. The scale of pollution in wastewater is alarming, and its impact far-reaching. It taints our rivers, reservoirs, and even the groundwater we rely on for drinking. It's a ticking time bomb for both our environment and our health. Now, here's where the concept of adsorbents comes into play. They are the unsung heroes in our battle against water pollution. These can be mineral, organic, or biological materials, like activated carbon, a popular choice in the industry. They play a crucial role in removing these harmful pollutants from our water sources. However, the high cost of conventional adsorbents like activated carbon often limits their usage. But how exactly do these adsorbents work in the battle against water pollution? Let's dive deeper. Adsorption, not to be confused with absorption, is a surface-based process where pollutants cling onto the surface of an adsorbent. This is a fundamental process in wastewater treatment, and it hinges on the simple principle of attraction. Imagine, if you will, a crowd of pollutants in a water source. They're just hanging out, causing trouble, but then they see something they're attracted to, an adsorbent. They rush towards it, attach themselves to its surface, and voila, we have adsorption. Now, one of the most commonly used adsorbents is activated carbon. It's like the superstar of adsorbents because it has millions of tiny pores that increase its surface area dramatically. This means it can attract a lot of pollutants. It's used extensively not only for removing pollutants from wastewater streams, but also for absorbing contaminants from drinking water sources like groundwater, rivers, lakes, and reservoirs. But here's the catch. Like many superstars, activated carbon comes with a hefty price tag. Its production process is complex and energy-intensive, which makes it costly. This is a significant limitation because, let's face it, we have a lot of wastewater to deal with, and we need a cost-effective solution. Moreover, activated carbon isn't always the best at dealing with certain pollutants. Some pollutants are like the bad boys in the crowd, not easily attracted to the superstar. They need something different, something that can draw them in and hold on to them. And this is where the story of adsorption gets really interesting. Over the past 3 decades, scientists have been exploring other materials, known as non-conventional adsorbents, to overcome these challenges. They're looking for cheaper, more effective ways to eliminate pollutants, even those at trace levels. So if conventional adsorbents like activated carbon are expensive, what are our alternatives? Well, stay tuned because we're about to dive into the world of non-conventional adsorbents. In the quest for cost-effective solutions, scientists have turned to non-conventional adsorbents. Over the past 3 decades, the world of chemistry has seen a rise in these unconventional heroes. These adsorbents, unlike their conventional counterparts, offer not only a cost-effective alternative, but also an efficient method for eliminating pollutants at trace levels. The journey began with the need to find a more affordable solution to the widespread use of activated carbon, a material that, while effective, comes with a hefty price tag. As a result, researchers rolled up their sleeves and delved into the world of non-conventional adsorbents. They explored a variety of materials, from minerals to organic and biological matter, seeking the perfect blend of affordability and effectiveness. The goal was simple: to develop adsorbents that could do the job just as well, if not better, than activated carbon, but at a fraction of the cost. In this quest, the scientific community has made significant strides. Today, these non-conventional adsorbents are not only cheaper, but also efficient in eliminating pollutants at trace levels. They have proven to be a viable solution in the battle against water pollution, showing us that sometimes the best answer is the one that thinks outside the box. As we continue to innovate and experiment, the future of wastewater treatment looks bright. So it seems we're on the right path towards more sustainable and affordable wastewater treatment. Let's quickly recap the key points. Wastewater pollutants pose a significant problem which conventional adsorbents, like activated carbon, tackle by liquid-solid adsorption. However, their high cost limits widespread use. Enter non-conventional adsorbents, the new kids on the block, promising more cost-effective and efficient pollutant removal. Over the past 30 years, numerous strategies to develop these unconventional tools have emerged. Remember, every step we take towards better wastewater treatment is a step towards a healthier planet. Thanks for watching, and stay curious.